Hi, I'm Steve Lasker. I'm a program manager that works on our Docker development experiences. Today I want to talk about that containerized workflow and what we're doing in our tooling to improve that. Now, you're likely working locally as you would with something like Visual Studio or Visual Studio Code. When you're working with containers, though, you're going to pull images locally so you can build locally. Now, one of the things that we've added is an Azure Container Registry, so you can keep those images within your data center and in your organization. And as you're building, you want to be able to push source code that's complete. You're going to debug and run locally, but you're going to push source. And then you want your build system to pull an image from the registry and then build it and then push the output of your build system into the registry for its deployment. You will not push code across, that's the brick wall there. You're actually going to deploy images to one of your multiple deployment targets. And in fact, in Azure, we are continuing to grow in our deployment targets from the container service to service fabric, batch, and app services is one of our newest workloads. So now you can actually deploy to a single container host very easily, scale it up, and then decide when you're ready for more complex scenarios where you need something more robust, such as the Azure Container Service. And then you'll round out that outer loop with telemetry and logs and so forth. Now, if you look at that slide, there's obviously some assembly required. We do have some batteries included, and we're going to see what we can do to make that easier for you with Visual Studio 2017. So let's get going. We're going to start with Visual Studio 2017, the release candidate. We'll choose the web application template, and we'll name it web as the name of our project. Now, the thing you'll notice here is under the web application or the .NET Core templates, we have the ability to add Docker support right from the get-go. This takes advantage of the Docker for Windows product that Docker makes available for hosting containers locally. We'll press OK, and this will give us our single project with the Docker capabilities in it. Now I can look at these Docker files, we can debug them, we can do the things that we have done with Visual Studio 2015 as well. Now in 2015, I could add another project as well, and let's go say add new project, and I can choose an API project, and I can go through that same steps to add that project to the solution. I'm going to cheat here and just switch over to one that I've already got set up. And now I've got a two-project solution, a web front end and an API. Now what we've heard is that developers want Docker so they can develop multi-container solutions. Now if I were to hit F5 here, I can start either one of these projects, but I don't have the way to start both. Now this was something that we looked hard at. We wanted to make sure that we could stay true to the Docker experience, which uses Compose for instancing multiple containers. And Visual Studio has another model for set startup projects, but this actually starts the projects individually. We want them to start from a Compose file. So a new feature that we've added, in addition to the add Docker support that you can add to existing projects, what we often refer to as brownfield projects, I can also add Docker support at the solution level. And if we look close, we'll see that I now have my project definition defined here at the solution level. You can see the image is web. It finds the context of a subdirectory for .web. And then I can do the same thing to my API project, and we'll merge that content in there. And if you look close, you'll see that we've got a new menu item that popped up here. Now what this does is, this is an example of we didn't have as much extensibility as we would like, honestly, in this menu option here. And so this is something we will change as we get closer to Visual Studio 2017 GA. But now what I can do is using this menu, I can start this up. And what Visual Studio will do is use that Compose file that we have at the solution to build and instance that collection of containers. And it'll start them in debug mode because we've got that as our profile. Now, the thing that you'll notice here is we opened up 2 pages. And that's because we told Visual Studio to open 2 projects. Right? And if we set a breakpoint here in our values controller, we can see that break. Did it stick? Yes, it did. We'll reset that. And we see our breakpoint has hit, just like I would expect. If I come over to the web project and I set a controller there, I can do a breakpoint in here as well. This has got some more information. We'll go to the contact information here to show that one. And notice we've got breakpoints in that. So that's pretty cool, right? We are now debugging 2 projects at the same time, but it looks like they're parallel projects. Let's make this a little more interesting. Now let's stop the debugger. And the first thing I want to do is tell Visual Studio, don't bother launching the API project. So in RC, you have to blank out that value. We'll make it work on the launch URL when we get closer to GA. Now, to make this again more interesting, let me put a couple other files that I've got in here. So I'm going to take these and drop them in our API project. And if I come to the web project, I can drop in the controllers and views over here, and we'll add that as well. Now, when I start this up, we're going to debug those 2 projects again. And remember, I told it to don't launch the API browser. Now, the other thing you'll notice is this started much faster. We did not actually have to build the 2 images for our 2 containers. We knew that you did not change the content of the Docker files, so we left the previous containers running. And notice I now have this magic link to get to our project. And I already have my image in there. We can make changes to that as well. So let's go take a look at our controller for our 8-ball. And we can go and say, if you do dare, we'll just stick something else in there. And if we refresh this, you'll see that we stuck that extra text in there. Now, the beauty there is we were able to do that edit and continue model, right? We were able to keep our container running and make a change directly to a CS/HTML file and have it refreshed here in the browser. Now, the other thing we can do is we can do breakpoints across those 2 solutions. So we'll come to our controller here. We will set a breakpoint on this line. And we will come to our controller and set a breakpoint here as well. So now when I refresh this page, we see that our web front end, notice I've got active tracking here. So we are tracking and stopped in our web container, and we get our normal debugger variables. And if I continue, it's going to go and see the breakpoint in our API controller. So now we are debugging across 2 different services running on 2 different containers on a Linux host on our Windows machine. So that we think is pretty cool, right? That's now you are really debugging multi-container services. So that's great. All right, now I've got that all set up, and that was one of the challenges people had in our previous product. The other thing that people are often asking for is 2 things. One, I want to be able to publish my app straight to place-to-host containers easily. And we had this initially, but it did not go through a container registry. Well, now we do. So now I can choose publish. I can choose a new profile. I can use the app services for Linux that also supports Docker containers here, and I can publish through this experience as well. Now, for the sake of time, I'm not going to go through this right now, because the other thing that people ask for is I have a fairly complex project here. I've got 2 containers. I might have a 3rd or 4th as well. And I really don't want to publish directly. I actually want a full CI/CD pipeline. So what we've done is we've worked with Visual Studio Team Services. We've worked with the Azure Container Service. We've added the Azure Container Registry. So now what I can do is, so what it's first telling me is I actually have to put this under source control. So that's a good point here. It's kind of hard to do continuous integration if I haven't actually put this under source control. So our project wasn't actually in source control yet. So we're going to go add it. And this is a feature that we had previously. So we're going to go through it kind of quick here. I'm just going to publish my app to Visual Studio Team Services. I'm going to create a special repo here. We'll call it the demo. That's fine. And we'll publish that. Okay, so now our project's under source control. And now we can come back over here and we can set up continuous delivery because you need source control there. So this is the new UI that we've set up because setting up CI/CD turns out to be fairly complex. And people often ask us for what is a good starting point? What is the prescriptive guidance? So what we've done here is we have this UI. It knows my subscription. It knows the project that I've just checked into and the repository. And now I can choose the Azure subscription I'm going to target. My container registry, we'll use this one here. So I can list all the registries I've got available. If you had no registries, we'd give you a link to create one, by the way, as well as the Azure Container Service. I happen to have only one. We believe you should only have one or two because the whole idea is the container service can run hundreds of different workloads. So I'm going to press OK. And what this will do is it will start provisioning the CI/CD pipeline for us in Visual Studio Team Services, setting up a build definition, a release definition, and setting up that going into our Azure Container Service. So down here, while this is running, we also have some additional UI that helps us understand some background tasks that are running. So this is a new feature that we've also been adding to Visual Studio 2017. So now that Visual Studio is finished configuring our CI/CD pipeline, we see we have a couple of URLs. We have our repository, we have our team project, and we have our build and release definitions. If we come over to VSTS, we see a bunch of steps that have been configured for us. Now, how many of you have had trouble where you have several different projects, each with their own dependencies for their build agent? It might be different versions of .NET, or in a microservice world, you might have somebody that's building Node or Python or Go, and each one of those agents have a different set of dependencies to build your project. So you wind up with all these custom agents that are these build agents for each project. And of course, as that app evolves, you have to go update that agent as well. So what we've done here is we've taken advantage of containers. We're going to actually use a container with our build dependencies in it and compile our code in that container. Now, it takes a little bit to wrap your mind around that one, so let's take a look. What we've done here is we have this docker compose-ci.build YAML file. And what that is it takes this image, it's going to volume out our source code into it, and then run these commands, and we can get rid of this command here. It's no longer necessary. We'll do a restore and a publish inside of that container. Now, what's really cool is we can actually test this here locally. So let's come over and we're going to come over to a command prompt and we'll cd into that directory. And what I'm going to do is say docker compose -f to get that docker CI build YAML file. And we're going to say up. And what it's going to do is instance that container, volume mount our source into it for our solution, and it's going to call restore and then publish on that. So we are simulating exactly what's going to happen in our build server. And we can test that locally before we're ever trying to check it in. Because what we want to do is empower the developers to own not only the target environment, but the build system as well. So let that run. We'll come back over here. So what we're doing here is we're going to build that in the container and take the source from the agent, build in the container, and put the published output back in the agent. The agent knows how to do Git. It knows how to communicate with VSTS. It doesn't have to know anything else. We could then run our unit tests in another container. The build container, if we notice, was built on our build image. And this is actually a little temporary here. This will look more like that when you are looking at the product. Oop, let's just try that one more time. That's what it should look like for you because it is ASP.NET Core build. It has the dependencies we need to build, such as gulp and bower and a bunch of other stuff, which I've already forgotten because I don't want to know. When I run my unit tests, I want to run my unit tests in the same environment that I'm going to run, which is our runtime image. So this unit test is going to use a different compose file that instances those. It'll volume mount our source. We can exercise our DLLs directly. Then we will build those images that represent our services. This is where we're actually doing the Docker build. We'll take the test results, publish those for VSTS. We'll do Docker push on the collection of services, not just one. We'll actually get the hash of each image and we'll merge those together so that when we are doing a deploy, we're doing a deploy on the hash, not just the label. As you get to use Docker more often, you're going to notice that people can change the contents of a label without it being compatible. And we don't want to do that. We want our deployments to deploy exactly what was tested. Now, if we go to the release pipeline, we'll see that we've got a definition here for deploying. Let's take a look. Let's edit there. And we have a dev, test, and production environment that we have scaffolded out for you through that UI in Visual Studio. And you see we have a deploy to ACS build step here, and it has been configured to work, in this case, with DCOS. And you'll see this expand over time to support other orchestrators such as Docker Swarm and Kubernetes. And you can promote these through these environments and so forth. So that's just a quick overview of what I wanted to show of the power we have in Visual Studio 2017 to work with Docker projects from the time that you are developing and building that project, debugging the single container, possibly publishing that to app service, or doing the more complex of CI/CD to the Azure Container Service. So that's just an example of some of the things that we've been doing with Visual Studio 2017 RC. We have our Docker developer tools that is part of this solution that we put together where you can build and develop locally. And then the other features for configuring CI/CD inside of Visual Studio and deploying to ACS are other features that we've been adding. So we hope you'll give it a try. We hope you'll give us some feedback. We hope that this is helping you get to your containerized workloads in a productive manner. So thank you for watching.